This video will cover beginner questions part 1 regarding the topic of trigonometric integrals. Case 1. If the power of sine is odd, we can rewrite as sine to the power of 2k x times sine x equals sine squared x to the power of k sine x. Then this one is here, then sine x, then this part save for du. The reason we formed the du by saving one sine factor is that we will use the power rule of u equal cosine of x. So use the trigonometric identity sine squared x plus cosine squared x equals 1. Then sine squared x equals 1 minus cosine squared of x. So sine squared x is 1 minus cosine squared of x. Now let's see how it is used in the problem. Question 1. If the power of sine is odd, but it is 1 as it is now, there is no need to save the sine separately. Use u substitution. Let u equal cosine of x. Then derive on each side. du equals minus sine x dx. Then times minus 1 on each side. Minus du equals sine x dx. Then back to the original. The integral of cosine is u. Then u to the power of 4. Then sine x dx is minus du equals minus u to the power of 5 over 5 plus c minus u was cosine of x. Then cosine to the power of 5 over 5 plus c. Question 2. If the power of sine is odd, then we can rewrite as sine squared x times sine x. Save one sine factor for du. And then cosine to the power of 4. Then dx. This part is du. Then sine squared x plus cosine squared of x equals 1. Then sine squared x equals 1 minus cosine squared x. Then back to the original. This part is 1 minus cosine squared x times cosine to the power of 4. Then sine x dx. Then use u substitution. Let u equal cosine x. Then derive on each side. du equals minus sine x dx. Then times minus 1 on each side. Minus du equals sine x dx. Then back to the original. The integral of 1 minus cosine x is u squared times u to the power of 4. Then sine x dx is minus du equals minus expand u to the power of 4 minus u to the power of 6 du equals minus u to the power of 5 over 5 minus u to the power of 7 over 7 plus c. The final answer is minus u was cosine of x. Then cosine to the power of 5 over 5 plus cosine to the power of 7 over 7 plus c. Case 2. If the power of cosine is odd, we can rewrite as cosine to the power of 2k times cosine x. Then cosine squared x to the power of k times cosine x. So this one is here. Then this is saved for du. And sine squared x plus cosine squared x equals 1. Then cosine squared x equals 1 minus sine squared x. We have to change it cosine into sine because du is cosine x dx. That means u equals sine x. Then du equals cosine x dx. Now let's see how it is used in the problem. Question 3. The power of cosine is odd. Then integral sine squared x, cosine to the power of 4x, then cosine x. Save one cosine factor for du equals integral sine squared x times, we can rewrite as cosine squared x then squared cosine x dx. Sine squared x plus cosine squared x equals 1. Then cosine squared x equals 1 minus sine squared x. The integral sine squared x times this part is here, 1 minus sine squared x then squared cosine x dx. Use u substitution. Let u equal sine x, then derive on each side, du equals cosine x dx. Then back to the original, the integral of sine squared x, that means u squared, times 1 minus u squared, then squared cosine x dx, that means du, equals integral u squared, let's FOIL 1 minus u squared times 1 minus u squared equals 1 minus u squared, another minus u squared, so 2u squared plus u to the power of 4, then 1 minus 2u squared plus u to the power of 4, then du, equals expand u squared minus 2u to the power of 4 plus u to the power of 6 du, then u cubed over 3 minus 2u to the power of 5 over 5 plus u to the power of 7 over 7 plus c. Then the final answer is u was sine x, then sine cubed x over 3 minus 2 sine to the 5th over 5 plus sine to the power of 7 over 7 plus c. When solving the integral problem consisting of sine and cosine, focus on the odd power and consider saving with du. If the power of sine and cosine are both odd and equal, then either of them can be set to u. I don't like negative sign, so I will let u equal sine here. So integral of sine cubed x times cosine squared x, then cosine x dx, this part for du equals integral sine cubed x times sine squared x plus cosine squared x equals 1, then cosine squared x equals 1 minus sine squared x, then 1 minus sine squared x, then cosine x dx. Then use u substitution. Let u equal sine x, then du equals cosine x dx. Back to the original. Integral of u is sine, then u cubed times 1 minus u squared, then du. And expand u to the power of 3 minus u to the power of 5 du equals u to the power of 4 over 4 minus u to the power of 6 over 6 plus c. Then u was sine x, then sine to the power of 4 over 4 minus sine to the power of 6 over 6 plus c. This is the last one. The power of sine and cosine are both odd and different. Since the power of sine is small, integral sine squared x, then save one sine factor, and then keep cosine dx. Convert the remaining factors to cosine. Use the trig identity. Sine squared x plus cosine squared x equals 1. Sine squared x equals 1 minus cosine squared x equals integral. This part is 1 minus cosine squared x, then cosine to the power of 5 sine x dx. Then let u equal cosine x, then derive on each side. Du equals minus sine x dx, then minus du equals sine x dx. So this part for du. So integral 1 minus u equals cosine, then u to the power of 5 sine x dx is minus du, then expand u to the power of 5 minus u to the power of 7 du equals minus u to the power of 6 over 6 minus u to the power of 8 over 8 plus c equals minus u was cosine x, then cosine to the power of 6 over 6 plus cosine to the power of 8 over 8 plus c. I hope this video has been helpful. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.